Hi there, and a really warm welcome to this week's eagerly awaited long tip. I guess it will be a long tip since there's so much to cover. So what I'm talking about is the compact disk shader tutorial that some of you or most of you have been eagerly awaiting. So let's grab your Windows 95 CD and let's get started. Alright, let's see what we are going to do today. So today we are creating a compact disk shader, or a diffraction shader, how it's called in physics. So we are after those colorful reflections that are seen here right now. So if you are looking for the whole scene with the CD, and this is the Windows 95 CD, you can get a hold of that when you subscribe to my Patreon. So if you like what I do here and want to support me, just consider subscribing to my Patreon and therefore gain access to all of the scenes I use in my tutorials. Also, small disclaimer here, this might be a somewhat accurate and physically plausible way to do diffraction shading inside of Octane, but it's by no means the best way, so I'm still doing this and I'm not a physics major. I'm just getting there with the limited knowledge I have. So if you know a better way to do that, let me know in the comments. With that being said, let's go ahead with chart time and have a look what's actually happening inside of a compact disk. If you watched my diamond material tutorial, link in the upper right corner right now if you're interested, you might think the effect from the CD comes from a refraction-based dispersion or aberration. Now, while it has similar properties in that it disperses the light in different colors, this is a completely different effect. And this has something to do with the waves of light. So what you can see on screen right now is a GIF that displays the double slit experiment, and it depicts the light as wavelength and therefore waves that interact with each other and therefore create pattern. And this is exactly what happens with an ACD. So let's take a closer look there. To learn is to look at stuff in detail, so let's look at a compact disk in detail and all its layers it's made of. So let's go with the bottommost layer, which is the polycarbonate disk layer. And this is basically the plastic you hold in your hand when you grab a CD. If you ask yourself where the data resides, it's basically the back of the plastic layer here, where those grooves are imprinted into the plastic. But the laser can't read only on refraction, so what it's done, it's basically put a metallic layer on top, so the laser is reflected back, and therefore it's able to read the information on the data layer. Since the metallic layer is really thin and prone to damage and therefore data loss, there is a protective coating, a clear coat on top of the metal layer to protect it against scratches and therefore keep your CD alive longer. And this is basically all this is needed for a CD, but on top of that, most of the CDs have a label, which is your favorite band, for example, or even Windows 95. And this is all there's to it. Let's jump to the next slide. Remember this from a minute ago, so basically this is the data layer of a CD, so we have two slits here, but a CD has a multitude of those slits due to its data layer repeating in grooves around the CD. So when we are looking at a CD, and let's ignore the metallic layer here that's reflecting the light for now, when we shoot light through the CD, what's happening is, due to wave dynamics, is we end up with 3 rays instead of 1. So how does physics explain getting 3 rays out of 1? Sometimes the light ray is depicted as a point or a particle, and sometimes the light ray is depicted as a wave. Now let's look at the light as a wave, as this supports the theory about light diffraction and so on. So when light hits the CD as a wave, it is possible to be reflected in all sort of direction. Now if you know about waves, waves can cancel each other out or amplify each other. So dependent on which direction the light is reflected in, it can amplify or even cancel out the light that is generated from the reflection of the disk. And therefore we end up with those 3 rays. Now let's have another look in a more practical example in Cinema 4D chart time. Okay, welcome to Cinema 4D chart time Wave Dynamics edition. So what we have here is two waves here. So those are two light waves of a certain wavelength. And the wavelength is the color of light. That's important to know. So if two wavelengths of the same color are exactly opposite to each other, the output is 0, meaning there is no reflection happening. But if we now move one of the waves more and more towards the other one, so they are aligning, you can see the output is actually double. So both of them are amplifying itself to be double the width of the initial wave. And this is basically what happens on a CD. So dependent on the angle the light is traveling through the medium, the light wavelength might be cancelling out some other light rays or amplifying some others, and therefore we get a distribution pattern that is also known as diffraction grating pattern. So let's look at this next. Okay, I promise chart time will be over soon, so let's take a deep sip of coffee so you don't fall asleep. Now, this graphic you already seen, so we have the data layers and the diffraction grating here happening with two distinct rays, but in reality we don't see two distinct rays, we see a rainbow effect. So the rainbow effect comes because we see different wavelengths of light as different colors. And every one of those wavelengths has a different cancellation and a different amplification angle. So we are amplifying different wavelengths at different angles and therefore getting this rainbow effect here. In my shader, I only will do the first order spectrum, and there is a second and even a third order spectrum, but they get weaker and weaker, so I thought maybe I can get away with only the first order spectrum, and as the renders show, I think that pretty much sold it. So the only thing that's different from our CD now is that we are missing the reflective metallic layer here, but if we install that, this is no much different there. It's just that we don't look through the CD, but the light shines back as a reflection. And this is all to it, and now this is chart time over. Welcome to Shaderland. So we jumped just out of one nerdy topic into another. This is the explanation how to do the shader in a very basic way, so to understand it first, before we jump into the CD shader and make it a bit more complicated. Okay, let's try to tackle this in a very easy manner first. So basically what we are trying to do is get 3 reflections out of the light source here, but those reflections are offset by an angle. So basically, if you think about it three-dimensionally, it is as if we would tilt our plane in one direction, so we get the one-angled reflection, and then we tilt it into the opposite direction, so we get the other reflection. And then, of course, there is the normal reflection that is straight up and not angled. So again, we want to create, without moving the surface, 3 distinct reflections of one object. Is that even possible? So how can we tilt a plane without actually tilting it? I thought about the bump map first, but there is no actual control over the angle that we achieve with that. So I got the next step up, and there's actually a map that does that, and as you might have seen, the material that sticks inside the normal map is exactly that. So what we are trying to do is get a normal map shader going that then changes the angle and therefore the vectors for the reflection to get what we are actually after in tilting the plane. I'm not going to get into details here, but those values are the values for a plain normal map, so when I don't do anything to them, we get a plane reflection, so the same as without normal map. And when we change the red channel, for example, we can sort of tilt this normal map to the side. And this is the effect we are going to use in this example as well as in the CD example later. Okay, so the plan is to convert this material to a submaterial so we can blend it with itself 3 times, so we get all the 3 layers of those rays together inside of one material and then can display it on the object. So let's do this by going to that, right click and go convert to submaterial. Select the submaterial, apply it to the object, and get active material. So this is our one metallic layer. So what we need is to duplicate that 2 times. So we have 3 for every angle. Here we go. So 1 angle, 2 angle, 3 angles. Also, what I'm trying to do is get all outputs to align. So we need to make another output here and assign that third material to material 3. So now, right now, due to the way the masks are handled, we only see the topmost material here. So we need to change that by going into the material 2 and change the mask to 0.5. So we have a 50-50 mix between those two. And then what we can do is get the third material in by not 50-50. This would mean that we have a 50 between both materials and a 50 between the bottommost, which is not the same amount. So we need to change that to 0.3333 since this is a third. Now we don't see any difference here, and this is because they all use the same angle. So let's change the angle and see if it actually has worked. And yes, we can now make our diffraction grating work and have one reflection that is then split up into 3 reflections or 3 distinct rays. Okay, this part is very difficult as well as very important for the rest of the tutorial. This is probably the 5th time I'm recording this, so hopefully I can get through it now. So what did we do? What do we do? So right now we split our light into 3 angles, but what we didn't do is get to the rainbow effect. And the rainbow effect is one of the essential looks of the CD, so we won't be happy if this was missing. So how do we get there? Basically, we keep on layering the materials on top of each other, and therefore also the shader might render forever, but this is how it goes. So we just take the middle material and I will demonstrate it on that, which is the reflection to the left. So here we go, we have our middle material. So when we click on that, what I want to do is go to Basic and enable Material Layers. So those material layers, if I then go to the material and go to the material layer, I can even add more shaders to it. So let's do this, but I don't want to add a shader straight away. I want to add a layer group because we need to add 2 more shaders. Here we go. And then add 1 metallic and 2 metallic layers. So here we go. We have again 3 shaders on top of each other that then connect to the 2 other reflections. So what I want to do here is first off render. And you can see that one of the reflections is gone now. And this is because we, in contrast to the other ones, we see the bottommost layer. So the layer 2 is visible and this one doesn't have the normal. So let's copy the normal map for every one of those shaders. Here we go. And as soon as we plug that into the most bottom layer, we can get our reflection back here. Here we go, there too. And then we have that. Now, this is just the same as before, so let's make something different here. So to split this up into different colors, into a rainbow, we need to have a rainbow colored effect here. So what we're going to do is do that with the specular layer. Now the specular layer here doesn't have a color, so we have to click on text. Sorry, that is out of frame, and go for a RGB spectrum. Here we go. And what I want to do is tint that pure red. Here we go. Now you don't see it because you only see the last texture right now, but we are going to go ahead anyway. So next we just pipe that into the specular as well. So here we go. And also that one is then pure green. And you can see where this is going. The next one also goes into the specular and obviously is pure blue. Now again, we are ending up just seeing the last one, but we want to have the same proportional mix as we did with our main reflection here. So what we need to do is go to the second reflection, layer opacity 0.5, and then to the last layer 0.333, And what you end up with is a image without any tint, because those three colors are weighted exactly the same amount, so they cancel each other out. Okay, we did a lot of work for nothing. We ended up where we started. So what is this about? Basically, what I can do now is go to our normal map here and change the angle for every one of those colors a slight bit. So let's do this. Here we go, something like that. And then go to the other one here and change it like that. So we need to make sure that the order is correct. So in our example, what we see is that the red color is always the most outer part of the spectrum and the blue color is the most inner part. But this is a way to do that. I'm going to figure out the right order and then come back to you. Okay, I'm back. So I also tidied up our nodes a little bit and also made a little bit more space for the nodes so you can see them better. So what I ended up with is a value of 0.8 for the red, a value of 0.7 for the blue, and for the green, and a value of 0.6 for the blue. Now you can see those dots are very separated and they are not really intersecting and building all these colors that we need. So what do we do? Basically, what we need to do is get a anisotropy going so we can spread them a little bit more around. So let's go with the blue first. So blue roughness, and make the roughness 0.4 here, so that makes it rather blurry. By the way, I'm using GGX energy preserving. If you would use Octane, this is the standard. The anisotropy will not work, so make sure you're using the right BRDF model here. So let's go back to the roughness anisotropy and set this to minus 0.8. Here we go. And you can already see where this is going. So let's do the same thing here. 0.4 minus 0.8. And then this here roughness 0.4. And then anisotropy minus 0.8. And now you can see we have like this colorful swoosh that is looking a bit like our diffraction pattern we are wanting to do. Now this shader here is limited in a way in that it's only one-sided. So it behaves as if the grooves are all parallel from the top to the bottom. And our shader for the CD is radial. So we need to find another way to mimic the angle here instead of using just a color shader. But basically this is it. This is what I came up with as an idea for the diffraction shader. We just want to do the same thing on the other side, just in reverse, so the red is also on the most outer part of the object. Now if you want to be super precise, you can get the angles through a formula and then trying to figure out the right angles with the normal map here, but I didn't do that as this would be taking it too far for this tutorial at least. Right, this is only a small step to a finished CD shader now, so there's only a small portions of things that we need to change out of this shader. But I wanted you to see the final result where I also did the second side, so the opposite side here of the diffraction grating. As I said, this is just the first order spectrum, not the second order, so there's no more spectra behind that. You would need another set of materials for that. And also, I think in real world, the grating would start a little bit more further than that, and you can do that by adjusting the normal map here. Now let's carry on and do the final radial CD shader. Alright, welcome to the last chapter, which is the CD shader. Now this is a lot of things we did before, but with some extras added to that. And as always, I encourage you to use a real-world example as a reference, especially with such complicated matters as a diffraction grating shader. You are best to see what light is doing with your CD in real world. So as you can see, when I shine light on the surface of a CD, you can see multiple things. First of all, you can see that the direct reflection is pretty strong. Also, you can see that the light is sort of falling off to the rims, sort of as the rims were kind of tapered, so cone-shaped. So what I did was I made a cone normal map. So let's jump into Cinema 4D and shade this inside of Octane. Welcome back to 3D and Shaderland. So now in this scene we are going to make the CD shader. We are going to just make the reflective part of the CD. If you want to have the full scene, then I suggest you become a Patreon. You get all the scenes I use in my tutorials, no matter what tier. Alright, next what we want to do is create the reflective part of the CD by creating a tube. Make the outer proportions that of a CD, which is 12 centimeters, and the inner portions of the reflective part of the CD is around 35 millimeters. So again, also the height, let's set it to 1. This is probably too big, but we can get the renderer some leeway here. And then the rotational segments, set this up to 128 to get a real nice round shape here. Here we go. Next, let's create the material by going to Materials, Create, and then go with a Octane Composite or Octane Blend material. That's the same material here. And then go ahead and click it so it becomes visible in the node editor. Inside of here, we are going to do the same thing that we did before. So we are going to the Basic tab, add one more material, and then create one material here. And get into the basics, go to Metallic and also GGX in the BSDF model. If you don't know about BSDF models, I also have a tutorial. It should pop up in the upper right corner right now. So what we're doing here is basically create the same shader that we did before, but with a radial behavior. And when I talk about this, let's render that and let's actually assign the material to the tube here. And maybe get the proportions a bit better, something like that. Okay, so what I'm talking about, and also get the light turned on here, is that with our CD, if you remember the video, the light is distorted in a radial fashion around the center of the disk. So instead of a normal map that skews to left to right, we sort of have to have a normal map that skews from the center away and towards the center. So what I did is I baked out a normal map of a cone. So when we have that here, that is basically a 45-degree cone, and we can then just plug that into our normal of the material. Now this looks a bit wild, and this is because a 45-degree angle is a little steep. So what we can do here is get the effect a little bit lower by going to our cone here and get the power a little bit lower. So a power of 0 means that we don't have any effect, and a power of 1 is the full 45-degree angle. Now, what I also want to do that I haven't done is go to the Material tag, go to the Tag option, and right now it's set as a UVW map, but I want it to be a cubic map. And let's display that. And I know that the diameter of this object is 120. So let's go here and set this to 120 for all of the axes. The cool thing about Octane and its normal maps is that it lets you tinker around quite a bit with it, in contrast to other renderers where you have to have normal maps for every situation and have to have really mathematical knowledge on how the vectors are formed. So for example, what Octane also lets you do is invert that normal map. For example, when we are looking at the light, we want to bend it outwards and inwards. This is the exact thing as what we did with the left and right side with our former example. So when we move the light to the side here a little bit, we can see more clearly what we are doing here. So we want to move it on this axis outside of the normal reflection, and then if we invert it, we want to move it inward, and therefore get the rainbow effect this way in a fashion that is radial. One thing to note is that our CD is basically mirror-like, and the coloring is a very small portion of it. So what I want to do is get this layer here and leave it clean, and make this the mirror-like layer, and then just tweak the other two layers to come in a right amount so we get the right mix behavior and therefore the right look. So in the following time lapse, I will build up the shader as we did before in the material. There's basically nothing new in there for you to know, and if so, I will mention it later. Alright, so let's sum up a little bit what I did here. Basically, it's exactly the same as with our linear diffraction grating shader, the only difference being the normal map used. So what I did here for the red channel is used a power of 0.5, for the green channel a power of 0.4, and for the blue channel a power of 0.3. Then I did the same thing with the normal map inverted, so this is the inverted version, this is the normal version, and this gives us our 3 separation of the colors for both sides, right and left of the reflection. Keen-eyed among you might have spotted that I left out a step, and this is the anisotropy. Now, the anisotropy has to be rotational here. We need to build that up a little bit different than to just slide a slider to a certain value. If you're not familiar with anisotropy, I did a whole tutorial on it. You can watch it in the upper right corner. It should pop up now. If you, for understandable reasons, don't want to watch the whole anisotropy video, I'm going to go and make this in a short manner of time without that much explanation. So let's go for the outer red part here and let's do an anisotropy on that, and then later in a time lapse assign it to all the other materials. So what you need for that is a gradient generator. Let's use that. Here we go, and show all. And then what we need to do is plug that into the rotation, as this being the anisotropic rotation here, since we are doing a streak around the center of the disk. Now there's some things we need to set up here. First of all, we need to set this to angular. Then we want to set the gamma to 1. And last but not least, in here we want to set this to invert. Now we are not done. We need a transform and set this to the transform slot, obviously, and then go to the rotation set and set this to 90. This is everything set up inside of this group. Now we need to turn our attention to the anisotropy, since it's not doing anything with a value of 0. Now we want to raise that to a high value of 0.9. Here we go. And if everything went right, let's render. We can see now we have a streak outward, and this is looking a little bit more like SCD. Now we are going to do the same thing to all the other channels. Alright, so we are done with our shader. There's just one more last thing we need to do. I think that's looking fantastic and very much like diffraction grating. And the anisotropy really helps to blend those colors together, like in real world. So the last thing we want to do is get to our shader above here and mix it in a right proportion with our direct reflection, as we've established at the beginning that the CD is really high on direct reflection and the diffraction grating only takes up a small amount. So let's go with a 25% for the refraction grating on either side, and you can see this is really coming together, looking fantastic, like the surface of a CD. So this is not completely physically accurate, but it gets close. At least it appears to have the same characteristics as a diffraction grating on a CD. Now, if you're worried that this shader wouldn't hold up, so I can turn it around and you can see that this shader stays in place as it would in a real compact disc. And therefore you can do all sorts of things with it, spin it in your CD player, in your virtual CD player, and don't worry that the shader falls apart. So hopefully that is the perfect CD shader for you. If not, if you have a better idea, let me know in the comments. Hope you liked it and hope you had fun. This concludes this tutorial. As you might have noticed, there is some massive research going on in the backend of projects just like this. So I'm really thankful for all the support I get from Patreon that makes those research times possible. So really huge and massive thank you for my 50 euro subscribers, Shields Augustinen and Leon Studio TV. Thank you so much for your massive support. Also a huge thank you for my 15 euro tier subscribers, Anton, George Luna, Jakob Fung, Just a Frickin', Chris Clemson, Lucas Pazon, Randall King aka Alessandro Bonchio, Marty Kane, Part 1 of 2, Raiko, Scene CGI, Shamus Johnson, and Yasin Rupp. Thank you so much. Again, if you like the content of my channel and want to support me, feel free to go over to Patreon and have a look at my page. The link is down in the description below. So this was it, our big compact disc tutorial. Hopefully it lived up to your expectations. Let me see your renders if you do some nice compact disc renders. I am eager to see it. Show it to me on social media, for example on Instagram or Twitter. I really can't wait to see all those shiny discs. Also, again, as this is a repetitive thing from the last two videos, if you're still watching, thank you so much for staying with me all that time. Please post a rainbow emoticon in the comments. And now, without further ado, this concludes this week's tutorial. Thank you very much once more, and happy creating! Bye!